You are welcome back to my YouTube channel. I remain my humble self, edu-aider. Thank you for joining me on Mathematics with edu-aider. Please don't forget to subscribe. When you watch the videos, make sure you like, give it a thumbs up, then make your comments known. I would appreciate this. And always try also to share with friends. Thank you for this. Quickly, we'll be talking about something today. We're on to binary operation. Binary operation. And under this concept, we'll be talking about the definition of this concept. Then we'll talk about the properties of this concept. Then we talk about solving with the properties that we've studied here. So let's go from the beginning. We have definition of it. How do we define binary operation? How is it defined? When you have binary operation, it's as simple as the what? It is the rule. It is the rule of combining elements. I can say rule of combining two elements. Let me use two because of the level I'm expecting to be watching the video. Two elements of a non-empty set. Of a non-empty set. Of course, the set, of course, is not the meaning of the set. A set is a what? A set of defined or defined objects. That is a set, defined object. Anything defined. It's like the definition on it, you know the pattern, you know the structure, you know there's a definition on that group of elements. It is a set. So here, it is a rule of combining two elements of a non-empty set with, okay, now, it is defined, because you need to define, it is also usually defined on certain symbols. It is defined on symbols. Let me use mathematical symbols. There are mathematical symbols such as you have this, 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 the asterisk. These represent multiplication. That time you use them interchangeably. These symbols, it could be for anything. Then let me say I have okay, I have this. So the elements will define on this, provided those elements are from what? A non-empty set. So here we have this. Stop here. Now I will be using, let me streamline into three other symbols that we apply using while I'm explaining this concept. I will explain this. It's just like E, but it's not E. This implies what? Belongs to. So I can have this. This is such that these are mathematical symbols that represent certain, phrases. So it belongs to such that, and this is there exists. So you permit me to use most of these terms while I explain under the properties. So this is just the definition. Now let's talk about the properties. Now, there are certain properties that bind elements on the binary operation. We'll talk about the first one. Let me talk about the closure property. Closure. When is a set of information or something like this said to be closed? When is it said to be closed? So that is one thing. When is a set said to be closed? So let me use this. Don't forget the two elements that are being defined by all these symbols, any of them rather, must belong to a non-empty set. So I can say a non-empty set is said to be closed. It's said to be closed if look at this, I'm using this symbol. If there exists, let me use elements A, B, these are just any element. You get arbitrary element. Could be anything. Can use XY, can use Z, E, can use anything. So we have element A, B. There exists this element. It belongs to a set of real numbers. Such that A the definition, I'm using one of the symbols. Here asterisk B also belong to this what? Set of real numbers. So that is closure property. If it's a non-empty set is said to be closed, if there exists A, B belongs to a set of real numbers, such that A asterisk B belongs to a set of real numbers. Then what happens? Let me give an example before I. Of course, you have 2 and 3 belong to a set of real numbers. So I can say 2 times 3 will give you 6, and 6, of course, belong to a set of real numbers. So which means what? This is closed. But if I say, let's say I have 2, I have, let me say I put 4 times square root of minus 6. And that will give me what? 4 root of minus 6. This does not belong to a set of real numbers. The square root of minus 6 will give me what? The square root of minus 1 times the square root of 6. And that will give me 6i. That will be 4 times 6i. Yes. And that's I is what? It's a complex number. So that's why this does not belong to a set of real numbers. So this, it means it is not closed. This one now is not closed. Am I communicating? So which means this definition is not closed under this. This set is not closed under this definition. Am I communicating? So we'll move to the next property. Let's go to commutativity. Now commutativity is, let me wipe this side. And I can also go this way. I can use a non-empty set, and I can equally use, okay, let me use an operation. Okay, I can use this. I can say an operation. Let me use, I don't want to use this again. Let me use this. An operation this is said to be commutative. Yes. An operation this is said to be commutative if, I want to use that my symbol again, if there exists A and C. Okay, let me use another alphabet now. Let me use C and D such that they belong to, they belong to capital letter D. Anything. So they belong to anything. They belong to this such that C plus D is equals to D plus C, and that belong to what? Belong to D, capital letter D. What does that mean? Now, if I do this, if I say C plus D is equals to D plus C, this is what we call additive commutativity. So this is additive commutativity. But if I say CD is equal to DC, it is multiplicative commutativity. You get that? So C plus D can be taken as D plus C. Any of them? No. C times D can be taken as D times C. That's multiplicative commutativity. So when C plus, okay, let me say now, you can't say if I have 2 plus 3 is equals to 3 plus 2, right? Correct. But you cannot say that 2 minus 3 is equals to 3 minus 2. Do you see this? They are never equal. So this means what? This operation, if I put minus here, in fact, let me use this operation plus. Yes, so what I use here? What I use here. So if you have minus and minus here, they are not commutative. You get? So let's leave this. Let's go to the next property. The next property I will talk about let's go to associative property. 3. So I'm talking about associativity. So I go associativity, a similar way of commutativity, but there is difference. Anyway, a difference. And I can say an operation. Let me use another operation. An operation. An operation. Let me use this. Is said to be associative over a non-empty set, if there exists x, y, z, this is such that x, let me use this, y, z. Follow me, follow me, follow me. So if you have this, you have there this x, y, z, so that x operating y, close the bracket, operating z can be equal. This is equal to y I can decide to write this way. Okay, this can be equal to, let's write it this way, y, z, then you have this, x. So if an operation, this is said to be associative over another set, if there is x, y, z such that this is equals to this. What do I mean? I have 2 times 3 times 4, which is the same thing as 3 times 4 times 2. Isn't it? The same thing. So this associative property. So associativity has been defined here. Let's go to number 4. Distributivity. Now, a set or an operation can be said to be distributive. I'm not choosing an operation now. If I'm picking this same element I used here, you have x, y, z, such that it's a different definition, such that you have x. Now, I'm going to be using 2 operations here. You have this, okay, this z, and of course, if you expand this should be equal to x this, open this, then you have this outside, then you have x, z, operate z, z. So this is what we call the left distributivity. Left distributivity. So this is distributive to the left. You can have it this way, or you have x, you are still having this as y, then you have this as z. Do you get? So this one can be equal to what? So you have, this means this is distributive, this symbol is distributive over this symbol. You get? So this operation is distributive over this operation. So here now I want to show this, right? This is right distributivity. So I can say this is x and you have this, are you seeing this? And you have your y, of course. Coming. Because it is right distributivity, you need to be very, very careful here. So you have this, then you have this center. So you have y operates this. You see this? So I can call this right distributivity. Well, in the next video we are solving a question. I will cover all these properties. So let me quickly go to the next one. Okay, now let me explain something here. Let me give an example. Example. It is commonly, it should be known, it has been discovered, that multiplication distributes over addition. And division, that does not mean division will distribute over subtraction. In fact, it does not. In most of the cases, addition may distribute over your multiplication and it may not, depending on the question or the set you are dealing with. But multiplication has always what? This is distributive over addition. So here, let's have something like this. You have 2 times open bracket 3 plus 5 plus 4. Do you see this? So how do we operate this? You just go by saying 2 times 3 plus 2 times 4, and that is equals to what? What would that give us? That will give us 6 plus 8, and that is just 14. But the other way around, it is not equal to this. Okay, I'm not supposed to conclude first, but because I'm sure, let's go. You have 2 plus open bracket 3 times 4. What would that give you? That can be equal to this can be equal to what? Plus 12. If you do it this way, you have 14, right? This. If you go this way, don't even go this way. So you have 2 plus 3 times 4, you have 4. You have 12, and that's 14. So here, you will see what happens is the multiplication distribute over addition, at the same time addition distribute over multiplication. But in some cases it will not be like that, and I've said division will never be distributive over subtraction. So let's go to the next property. Okay, let me write the property here. So you have 5 identity. Yeah, so when we talk about identity, it's something that is common, that we use generally, we use every time. If you have a number, most of the time we all consider in mathematics 1 to be an identity. But 1 is not the only identity we have. We have 0 and 1 as the 2 identities that we have. Now, a number, an element, let me use an element. A is said to have an identity E if A is operating E, that gives us A. So this is the only condition where we have an identity. That is, when an element operates its own identity, you will still have that element back. Example, you have, okay, I'm using the same here. A times 1, it is A. Here, 1 is the identity. If you have A plus 0, it is still A. Here, 0 is the identity. So you say 0 and 1 are identity. So don't let me, just like I said for commutativity, that we have additive commutativity and multiplicative commutativity, we also have additive identity, which is 0, and we have multiplicative identity, which is 1. So that will take me, without your identity, you cannot have the next property, which is the inverse property. So let's consider the last property for this session. So we have the sixth property, inverse property. Let me use a definition that is close to what I've used before. An element A is said to have an inverse. if A operates, it's not compulsory I use this, I don't want to use this again. If A operates its inverse to give you the identity. So we say E is identity, then A inverse is the inverse. So these are the definitions we use when you are solving the question. You must be able to relate the element with its inverse and its identity, which means if there is no identity, we will not have inverse. So the element operates its inverse. Let me give you a common explanation that most people will not be able to relate with this. You have 2 times the inverse of 2 is what? 1/2, and that will give you 1. And I said here before that 1 is an identity. So that's how we generate the identity, and that is how we work with it. So in the next video, we'll treat a question that will solve, that will use all these properties to deal with and makes life easier for us. Please don't forget to subscribe, make your like, then also make your comment. I want to hear from you. Any observation, any correction, of course, I can learn from you. Any recommendation, I would love to hear that. Then also, if you want to reach me, don't forget you can reach me on +234 81 64 86 9470. Thank you very much.